Hey class, it's Mr. M here to help you with your trigonometry homework with a couple of examples. I have three problems here. The first one is pretty easy, the second one a little bit harder, and the third one harder still, but let's go ahead and tackle them. The first question deals with finding simple trig ratios. Find these four trig ratios. So let me give you a moment to think about it, maybe pause the video and see if you can figure it out. Alright, if you've unpaused it now, you might notice that there's something missing in this picture. And that's going to be an issue, but it's actually not too bad. So we'll have to figure that out. Sine of angle A. Alright, so angle A is right here. Sine, I always like to write SOHCAHTOA out for all these, just so I can refer back to it. SOHCAHTOA. Sine is the ratio of opposite to hypotenuse. So from angle A, opposite is 3, hypotenuse is 5. So that would just be plain old 3/5. Fair enough. Cosine of angle A. Cosine of angle A. That gets more complicated, doesn't it? Erase some of these. Cosine of angle A is adjacent over hypotenuse. Looking right here, adjacent over hypotenuse. So I know that it's going to be adjacent over hypotenuse. We know the hypotenuse is 5 because it's across from the 90-degree angle. But we don't know what this adjacent side is, right? It's unknown. I'm going to call it A for adjacent. We don't know what it is. Well, we can find it, though. So before we do anything further, we need to find this missing side. So I'll do it here in this little cloud. Can you think of a way that connects A, 3, and 5 together, given that this is a right triangle? Well, hopefully a light bulb is going off in your head, and that light bulb is saying the Pythagorean theorem. So A squared plus 3 squared is equal to the hypotenuse squared, which is 5 squared. So A squared plus 9 equals 25. Subtract 9 from both sides. You can probably see where this is going. A squared is equal to 16. Take the square root, so A is equal to 4. So A is just 4. And I chose a very easy example here. Most of you probably know about the 3, 4, 5 right triangle. But if not, it's a good one to know. 3, 4, and 5 always make a right triangle. So A is 4, so the adjacent side is 4, so cosine of angle A is simply 4/5. Sine of angle B. So now we're looking at this angle over here. Sine of angle B. Once again, sine is opposite over hypotenuse. Across from B is 4. Opposite of B is 4. Adjacent is, hypotenuse is still 5. Sine opposite over hypotenuse. So still 4/5. Now if you paid attention in class, then you know that sine of B is going to equal cosine of A. Why? Because A and B are complementary angles. Of course these are equal. The opposite of one is the adjacent of the other. And finally, tangent back at angle A. Tangent is the ratio of opposite to adjacent, right? So opposite of angle A is 3, and adjacent to angle A is 4. So 3/4. Alright, let's take a look now at a second type of problem once you've soaked this in. And it's a bit more complicated, but we can tackle it. Find the perimeter and the area. Now one thing that you should already know, it's a pretty basic fact, but if you don't, the area of a triangle is 1/2 the base times the height. And the perimeter is just all the sides added up, so that's not really a formula. Well, we have one side here of 10, the other two sides are missing, so that's not good. So let's try to figure out what we can know about this shape. Well, at least let me give these some names. I forgot to give these names. A, B, and C. Angle B is staring me in the face, right? It's not given, but it's really easy to figure out. I mean, come on, 90 and 40, right? Those are 130 together, which means angle B must be 50. Or, once you get in the hang of it, you know that these two angles, C and B, must be complementary. So 90 minus 40 is 50, right? So that's 50. Okay, well, I'm missing two sides, right? I'm going to label these here to make it a little bit easier for us. I'm going to call them X and Y. I don't have X, nor do I have Y. So I got to figure out some way to get those. What I do have is this 10, and we know that it's the hypotenuse. Why? Because it's across from 90. So refer back to our old friend, SOHCAHTOA. And let's try to find x. You can find y first, doesn't really matter, but I want to find x first. Finding x, okay. Well, I'm going to pick the 40-degree angle because that's what's provided to me here. I had to figure out the 50, but we'll see if we even need the 50. So relative to angle C, which is 40 degrees, x, so again, relative to angle C, x is right next to it, or adjacent. And the 10, well, that's still a hypotenuse. So adjacent hypotenuse. Looking at SOHCAHTOA, there's only one of these that has adjacent and hypotenuse, and that's cosine. So cosine of angle C, which is 40 degrees, cosine of 40 is equal to adjacent, unknown, calling that x, over 10. Cosine of 40 is the adjacent over the hypotenuse, which is 10. Alright, so cosine of 40, simply look it up in a trig table if you're doing it the old-fashioned way like we looked in class, or do it in the calculator. Now you will need to make sure it's in degree mode. Cosine of 40, calculator tells me that that is 0.766. And that's equal to x over 10. Well, the right-hand side's a fraction. I'm going to make the left-hand side a fraction as well, and now it becomes very easy to connect this to the idea of similarity, which this stems from, right? Proportions. So cross multiply, you'll get 7.66 for x. And there's x, 7.66. We didn't know it, but now we do. Well, we're almost there. We still need y, right? We still are missing, we choose a different color, we're still missing this side over here. Well, there's a variety of ways to go. You could use the Pythagorean theorem, right? Y squared plus 7.66 squared equals 10 squared. You could do that, nothing wrong with it. I'm going to stick to trig just because I think practice will help us here. And this time I'm going to use the 50-degree angle. Alright, so relative to 50 degrees, y is adjacent, right? It's right next to 50, so it's adjacent to 50. And 10, the number we're given, is still the hypotenuse, right? So we may as well use that 10 because we know for sure that's right. So adjacent hypotenuse, well, that's going to be cosine again. Cosine of 50 is equal to adjacent over hypotenuse. Cosine of 50 is looks kind of weird to me, so let me just make that a number. 0.643 according to the calculator. 0.643 in degree mode equals y over 10. I'm going to make that over 1 so I can cross multiply a little bit easier. And that's going to give me 6.43 equals y. 6.43. Okay, so we didn't have x, we didn't have y, but now we do. And if you notice, we now have all three sides, which I'm highlighting here, and, incidentally, we also have all three angles. Let me highlight these. Angle, angle, angle. So we've done what's called solving this triangle. We found everything that is possible to know about it. All three sides, all three angles. So let's go ahead and answer the original question. Find the perimeter and find the area. Well, perimeter is just all three sides added together. That's 6.43 plus 7.66 plus the 10 we were given. And that will give you 6.43, 7.66 plus 10 will give us 24.09 linear units. And area is 1/2 base times height. Well, the base, from my perspective at least, I would call that 6.43. But if you want to call it the height, just turn your paper around and there it is. So base times the height, that's the other side, 7.66. And this will give you 1/2 times base times height. drumroll, is 24.63 square units. And there you have it, perimeter and area. Finally, let's take a look at a challenge problem. This is similar to number 12b on your homework. Find all missing parts. Okay. Now this is tricky. We don't have any angles at all, right? Look back at the previous problems. We had 40 degrees, we had just ratios here, but here we don't have anything, right? We just have two sides and we don't have any parts. Let me call these H, C, and D. We don't have angles H or D, but all we have are those two sides there. Okay, well, how are we going to do this? I'm going to try to find angle H first. It doesn't matter whether it's H or D, but I'm going to choose H. So angle H, how do you find it? Well, I do know that 4.1 compared to H is opposite it, right? It's directly across. And I also know that 9.2 is the hypotenuse. So if I knew angle H, I could do something with, sine or cosine or tangent with opposite and hypotenuse. So I'm going to look at SOHCAHTOA here again, as ever. SOHCAHTOA. Okay. Opposite, hypotenuse. Let's see. Opposite, hypotenuse, well, that's sine, right? So sine of whatever the heck angle H is equal to 4.1, opposite, over hypotenuse, 9.2. Okay, well, I know both of those numbers, 4.1 and 9.2. I can just divide those and get a ratio, or a decimal, and that's 0.446. So all this is just 0.446. That's sine of H. And this is the part we talked about right at the end of class, in that you can use a table of data in two directions. If you know an angle, you can find a ratio. Here we know a ratio, we can find an angle. We can go in reverse, or we can go in the inverse direction. So I'm going to switch these around. This is just a bit of notation to make it more clear as to what's happening. H is the angle, and I'm not going to take the sine of something I don't know. I'm going to take the inverse sine of what we do know to find the missing part. So what was sine of an angle H is now going to be the inverse sine of the ratio 4.1 over 9.2 to give us angle H. So in your calculator, you're going to hit the second button, like shift, and then press sine. That will give you inverse sine of the ratio that we just found. Opposite to hypotenuse ratio is 0.446. The inverse sine of that ratio will give you, in the calculator produces 26.49 degrees. Let's just call it 26.5. And there is angle H. That was relatively painless, right? Set it up the exact same way, except we don't know the angle this time. You still get a decimal, right? You still find something, except this time you don't type in sine of an angle to get a decimal. You type in the inverse sine of the decimal to find the angle. So now that we know that H is 26.5 degrees, there's a variety of ways we can go. 26.5 degrees. Well, angle D is still missing, but you already know that all triangles make 180. And in a right triangle, H and D here must be complementary, right? You've seen this before with theta 1 and theta 2 in class. So angle D is simply going to be 90 minus 26.5, which gives us 63.5 degrees. So there's angle D. All we're missing is this side here, which you can find using the Pythagorean theorem. And just to save time, I'll tell you, because you know how to do the Pythagorean theorem by now, you'll find x is equal to 8.24 units, approximately. There you go. It's kind of a long video, but I wanted to show this to you because we had a shorter class today because of the weather, but I hope this helps you out.